Hello everyone, I'm Frank and welcome to Frank Puzzles. This is today's very hard difficulty puzzle and we'll see how long this takes me to do. I've done what I believe one other very hard puzzle and actually wasn't that bad. I think it took me about an hour or so. Anyways, we'll see how this goes. And today's puzzle is called Renban Circus by Jeff Wadges. I don't know how I pronounce it. Anyways, here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every box. Each purple line contains a set of consecutive non-repeating digits which can appear in any order. And these are called Renban lines, or we call them Renban lines. And for example, if this was a 1, this would have to have a 2 and a 3 on it. But we don't know what the order is because it has to be consecutive. And 1 can only be next to 2 and 3 for 3 digits. Using red, green, and blue, color in all circles such that 1. Orthogonally adjacent circles are different colors. 2. Colors on the same purple line are the same color. Okay. And 3. The digit inside a circle appears that many times in circles of that color. Okay, so this is interesting. Okay, so again, we have to color in all the circles, and there's a lot of circles here. Orthogonally adjacent circles are different colors. So orthogonally just means that they share an edge. So for example, these two cells are orthogonally adjacent. These two cells are not. They are diagonally adjacent. So you just have to care about orthogonally adjacent ones, right? Circles on the same purple line, which is just these two and these two, are the same color. So these two colors have to be the same and these two colors have to be the same. The digit inside a circle appears that many times in circles of that color. So for example, let's just say all the circles that are not green or red. Let's just say all the circles were blue. Okay. Let's say all the circles were blue. That means if you saw a 7 in that blue circle, that would mean there would have to be 6 other 7s in blue circles around the puzzle. And so that would mean seven circles and blue circles in total would have 7 sevens. Now, if you could also have like a 7 and a green, and that would mean that there would have to be 7 greens, right? Or like say you had two blues, 2 greens, and 2 reds, right? That would mean that there would have to be 2 circles, 2 twos in blue circles, 2 twos in red circles, and 2 twos in green circles. So they're counted separately, essentially. And those are all the rules of the puzzle. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, this should be interesting. First, for any circle puzzles or this specific type of circle puzzles where basically the digit has to be counted at least somewhat, I like counting the total number of circles because that gives you just a baseline of what the total amount can be, right? Now, this is a little spin on it because red, green, and blue are completely different, right? So one thing we know, okay, so this is red or green. This is red or green. Okay, so let's color, maybe we should just color in all the ones that it cannot be. So this is blue or green. Remember, this is diagonally, not orthogonally adjacent. So this could actually be green. This is also red or blue. This could be any of them, so we're not coloring any of those in. These are blue or green. These are blue or red. This is green. This is blue. Oh, okay. So these have to be uniquely. So this is a pair here. This is a blue-red pair. This has to be red. This also has to be red because they both touch blue and green. These both have to be green. So this is blue or green. So this is also blue or green. This has to be blue or red. And this also has to be blue or red. There's nothing orthogonally adjacent to this. This is already taken care of. So these two are the same. And those are all the orthogonally adjacent ones that we see. Now let's count up the circles. There's 6 plus another 6, which is 12. So one thing that I thought of when I was talking about the rules is there can only be 1, 5, 1, 6, 1, 7, 1, 8, and 1, 9 in any of the sets. So if there's a 7, say, in a green set, it cannot be in blue and red because there has to be 7 sevens taken into account. And you can't have another 7 sevens in one of the other sets because there's only 9 total. 9 7 total. So that's the same for 5 through 9. So you can have at most 35 counting the 5 through 9s. Now, 1 through 4s is a different proposition. 4, you can actually have 2 different sets. 3, 2, and 1, you can have 3 different sets each. Actually, let's calculate that out. So 5 through 9 counted once is 35. 4 times 2 is 8. So 35 plus 8 is 43. 43, so it's plus 1 plus 2 plus 3. So that's 6 times 3 is 18. So you have 43 plus 18, which is 61. So you could have at most 61 circles. I don't think there's that many. I don't think there's actually that even close to that. So we know it's past the, it's lower than the boundary, or it's probably not up to the boundaries. So this is 6, 12, 17, 22, 26, 28. We have 5, 28, 33. This is 40, and we have 45. So it could be 1 through 9. Yeah, it could be 1 through 9. It could be some variation of that. Does it have to have 5, 6, 7, 8, and 9? No, right? Right, because we said it was 61, so there's 16 left. So there has to be an 8 or a 9, though. There does have to be an 8 or a 9. Okay. Because it can't be 16. Right, we have 45, right? If you subtract 61, if you subtract 45 from 61, that would mean 16, right? Which you can subtract out a 9 and a 7, but you can't subtract out a 9 and an 8. So there is either an 8 or a 9. We don't know which. And it could be both. It could be both, right? It could be 1 through 9. Let's just double check the numbers, right? 5, this is 10, 15, 20, 25, 30, 35, 40, 45, and there's 5 in each column. That's interesting. There is 5 in each column. Okay. I don't know if what that tells us, but oh, interesting. Okay. There cannot be a 9. We know that for certain. So, say there was a 9, right? Where can the 9 be in row 6? It has to be either in a green or a red. But the problem is, it would also have to be in row 5. Where can it be in row 5? It would if it's green, it has to be here. But then they see each other, so that's not possible. If it's red, it would have to only be here. But that can't be red, because that can't be 9, because 9 would have to be possible here. So therefore 9 is ruled out. So we know there's an 8 There is no 9 because you could have at most 61, right? So 61 minus 9 is 52. And then you only have 7 more spots to let go. So there's either a 7 that's not possible, or there's like a combination of 1, 2, and 4, or it could be 2 2s and a 3, or something like that. So that means 5, 6, and 8 have to be in a set. They don't have to be in the same set, but they have to be in a set. So one of these has to be 8 because of the same problem, right? One of these has to be 8, and we know it's an 8, right? Let me double check. Okay, so 5 through 9 is 35. 4 twice is 8. So 8 plus 35 is 43. 1, 2, 3 can be all 3 times because there's 3 different sets. So it's 6 times 3, which is 18. So 18 plus 43 is 61. Yes. So 61 minus 9 is 52. So there's 7 circles that we are not taking into account, not including the 9. 9s cannot be in any of the circles. Oh, so actually this tells us where the 9s are, actually. And these are also Renban, too. I forgot about that. So one of these, interesting. One of these has to be 9, which means one of these has to be 8, and the other one has to be 8, right? So this, interesting. So if this is 9, that would mean this would have to be 8, which would mean that's 8. But one of these obviously cannot be this one. So one of these 4 has to be 8 because of this 8. So the 8 cannot be here. So the 8 has to be one of these 2. Right? If this is 9, this has to be 8 because we have to have an 8 here. So that can't be 8 anymore. So this one has to be 8. And therefore, one of these 4 would have to be 8. It cannot be this one. So one of these 3 would have to be 8, if that's the case. If this is 9, that means 8 could be one of these 3. This cannot be 8, so this would have to be 8. So 8 could be one of those 4. So 8 could be one of these, essentially. 8 has to be one of these. Wait, hold up. Yeah, I guess it's possible. Never mind. That's fine. So, okay, we know there's an 8 here and an 8 here, which means in every other box that does not contain these 2, there has to be an 8. And it has to be red or green. It cannot be blue. On top of that, okay, so it can't be blue, so this cannot be 8. So the 8 cannot be here specifically in this row. Therefore, this cannot be 8, right? If this was 8, that means there was also an 8 somewhere here, which is not in a circle, which is not valid, right? Because then there's no more 8s that are possible. So this cannot be 8. This cannot be 8. One of these 3 is 8. So one of these, oh. And since one of these 3 is 8, this can't be 8. Right? So say this was 8. If this was 8, this couldn't be 8, so this would have to be the 8. This would be 9. We know this cannot be 8, so there has to be an 8 here, and it has to be in green. And so the only 8 would be here. But then there has to be an 8 here, and it has to be green, which is not possible either. So this is not possible. So We know this can't be 8. There has to be an 8 here because it cannot be in blue. And we've already found one 8 that's on a Renban line, which is not in a circle. So that means all the other boxes have to have that are not touched by that Renban have to have an 8, which means it has to be red or green, which means it has to be here, which means this cannot be 8. So since this can't be 8, this can't also be the 9 either, because there's no possibility for 8 or 9 there. Therefore, this is 9, which means this is 8. So this cannot be 8. This has to be 8, and it has to be 8 with a red circle. So 8 is in one of the red circles, so this can't be 8. We know the 8 is in one of these 3. The 8 has to be in one of these 2. The 8 has to be in one of these 4. This could be 8. One of these 2 could be 8. So this is 8, this is 8, and that's the 8. So the 8 could be here, here, or here. So those are the possibilities for 8. 8 cannot be here. 8 could be here, or 8 could be here. Okay, so those are the only possibilities for 8. Now we have, okay, so we have 5 and 6. We don't know if we have 7. So it's either 7 is not there, or 1, 3, and 1, 4 is not there. One set of 3 and one set of 4 is not there. So we definitely have a 4. We definitely have 1, 4. We have a 5, a 6. We already have the 8. So we have 8, 5, 4, 5, and 6. There could be an extra set of 4. So we're missing either a set of 7, a set of 3 and 4. Oh, wait, no. 5 and 6 are not guaranteed. It could be a set of 1 and 6 also. Right. It could be a set of 1 and 6, and you have 2 other 1s, and 3 sets of 2, and 3 sets of 3, and 2 sets of 4, and a 5. Or it could be 2, 5. So it could be 7, 1, 6, 2, 5, 3, 4. It could be 1, 2, 4, or 1, 3, 3, or 2, 2, 3, or 1, 2, 2, 2, or 1, 1, 1, 2, 2. Right, those are all possible. So we know this is 9. Okay, we also know this is 7. So we have 7 and 9 taken care of. This cannot be 7 or 9. So this can't be 9. This could be 7, and it could be like 6, 5. Or this could be 1, 2, 3, 4, 5, right? So there's that. 9 has to be one of those two, because this cannot be 9 anymore. We know the 8 is in a red, but it cannot be here, right? Where is the 9 here? So 9, okay, 9 cannot be here because it can't be on the Renban anymore. Because the 9 would have to have an 8 with it on the Renban. So the 9 has to be one of these 2. The 9 has to be one of these 3 because it can't be in a circle. So the 9, we have the 9 accounted for here in row 1 and 2. We have the 9 accounted for here in row 1 and 2. Therefore, nothing on row 1 or 2 could be a 9. Therefore, that's a 7, and this is a 9. So this is a 7. Okay, and the 7 could still be not in a circle. It could be in a circle too. Also, we don't know. So 9 has to be one of these 2. 9 is one of these 2. 9 is one of these 3. 9 is one of these 4. That's not helpful. 9 is one of these 4. And 9 is one of these 4. Or 3. So 9 has to be either here or here. Okay. We have the 8s taken into account. There's 5 circles in each row. So this cannot be a 7, right? So if there is a 7, the 7 cannot be here and the 7 cannot be here. Therefore, the 7 has to be in each row. But there's not that many limitations on that. Okay, so if this was a 7, this would have to be 5 and 6. And it would also mean that 7 is the one that's out. Right. I'm not sure if that's helpful. These are consecutive. Okay, that's interesting. Oh, interesting. Okay, what happens if this is 8? If this was 8, that would mean there would have to be a 7 along it, and it would both be red. We know there's no 7 here. This could be the 7. This would have to be the 7. Okay, so if this was 8, let's just take this into account. If this was 7, 8, it would have to be with a 7 because it can't be with 9, right? So one of these was 8, one of these is 7. They would both have to be red because the Renban circles on the same Renban line are the same color. So these are both red. There cannot be a 7 in this row. And there doesn't have to be one there, I guess. We know there's one here. I don't think that eliminates very much. Okay, so 8 is either here or here. If this is 8 and red, these would both have to be green. What's the most in a row? 7. So it could be 1 through 6, and then also withdraw the 7. I mean, it seems plausible. Hmm. Okay, I'm gonna pause. I need to go to the bathroom right now. Okay, and we're back. Sorry, I had to go to the bathroom for a little bit. Let's continue. Um, where was I? So there's something that adds up to 7 total, which are not in the circle. We know there's a 4. We don't know if there's a 5, a 6, or a 7. There could be 2 sets of 4, but we don't know. Hmm. Interesting. Hmm. If there are 3 sets of 3, this has to be 3. Oh. Just like there's no 9s, there cannot be 3. Right. Okay, so if there are 3 sets of 3. Okay, yeah. Say there are 3 sets of 3. This would have to be a 3. There would have to be a 3 somewhere here. Oh, wait, no, that does actually work. uh, nothing there. Yeah, never mind. That actually does work. Right? The whole point was that you couldn't have the 3 and then one of these would have to be green or red, and then didn't have another one here. In this one, you have to have 3 separate sets, right? So the 3 could very well be here, and then you would have 3, and that would work out perfectly fine. So that is possible. Assuming that there's 3 sets of 3. So if there aren't, what does this have to be is the question, right? Oh, interesting. Okay. Huh. Okay, the thing is, this set of Renbans is interesting because it limits certain possibilities. Right? So, if this contains a 3, we know for certain that you cannot have 3 sets of 3. So then you're guaranteed a 7 and a 6 and a 5. Yeah, you're guaranteed 5, 6, and 7 if that's the case. If this has any 3. So if it's 1, 2, 3, 2, 3, 4, or 3, 4, 5, then that means 5, 6, and 7 are guaranteed in the circles. If you have a 5, 6, 7, you're guaranteed that 7 cannot be in a circle, right? Because 7 cannot be in any space here, and then 7 would be also here. So that would be 3 that are outside the circle. So if it's 5, 6, 7, you know that the 7 cannot be in the circle. If you have anything with 3, you know that at least 3, it's either 3 and 4, 1, 3, 3, or 2, 2, 3. Or, yeah, those are the possibilities, right? No, it could be even like 1, 1, 2, 3. Yes, 1, 1, 2, 3 also works. So right now we're from the pool that we have 3 sets of 1, 3 sets of 2, 3 sets of 3, 2 sets of 4, a set of 5, a set of 6, and a set of 7. So those are the possibilities that we can have. We have to remove 7 total amount from that, right? So if this is 5, 6, 7, the 7 cannot be is outside the circle here. The 7 is outside the circle here, and the 7 has to be outside the circle right in these 6 cells. in row 6. So therefore the 7 takes care of all the numbers that are there. So everything else has to be there, right? Which would mean that's a 3. If this is anything with a 3 in it, that means one of the 3s is gone. One of the sets of 3 is gone. And it could be a set of 3 and a set of 4. It could be 2 sets of 2 and a set of 3. It could be one set of 1 and 2 sets of 3. Or it could be 2 ones, a set of 2, 2 sets of 1s, a set of 2, and a set of 3, which is not in the circles. But that does limit the 3s. So we don't know what this is, though, from that, right? Yeah. This could be 1 through 6. We don't, I mean, this is 1 through 6. We just don't know what. This is also 1 through 6. This is also 1 through 6. These are also 1 through 6. Right. Right. The only problem is, what does 4, 5, and 6 do, right? If this is 4, 5, and 6, we don't have anything that's guaranteed to not be in it, right? It could still be the 7, that's not correct. It still could be 1, 6, it could be 2, 5, it could be 3, 4. Because this is only 3, right? This is only 3, and they're not limiting anything else. Okay. Hmm. So all the green spots, we only know that there's 2 distinct numbers. All the blue spots, there's 2 distinct numbers too. All the red spots, there's a lot of red spots. There are no distinct numbers, interestingly. Well, okay, there's 2. Yeah, I don't know how helpful that is, right? We know what's the least, right? There could be. We know everything has at least a set of 3 or 2 or 1, right? You can. Oh wait, no, that's not true. It could be 1, 1, 2, 3. Right. Hmm. So there's only 4 here. There's only 2 here. The rest have 5 or 6 or 7. The rest of the rows and columns have 5, 6, or 7. Huh. The blues are different. I don't think it could be 4 blues. Maybe it could. I don't know. And then we have the Renban too, which have to be the same. Hmm. Yeah, this could be the same as this, right? Well, that's interesting. Okay, so this. Okay, where is this one? This one cannot be green, so it's one of those 3. And it cannot be this one. It could be one of those 3 also. So it's one of those three. Oh, it has. Wait, no, no. Okay, wait, no, it doesn't have to be. It doesn't have to be. If this is 8, though, okay, so maybe figure out what happens if this is 8. If this is 8, this is red. So this is 7. So this would have to be 8. This would have to be 8. Okay, so 8's one of those two. 8 cannot be here, so this would be 8. Therefore, that would be 8. 8 would be one of those two. 8 would be one of those two, right? So 7 also would have to be a red. So 7 would have to be here, right? This would have to be 7, and it would have to be red. This is the only other 7 possible, and this would have to be 7. Because we know the 7 cannot be in this row. It's already not here. So then one of these two is 7. That seems plausible. One of these two is 7. So this would have to be 7. Ah, and it doesn't work. Okay, so it cannot be 8 here. So we just tried that with 8. So if that's 8, this has to be 7. They're both red. The 8 has to be here and here because it's red. 8 would have to be here. 8 would have to be here, then one of these two, then one of these two. 7 would be here, and it's red. That's the important thing, right? 7 cannot be here. I guess this could be 7. Oh, but where is the 7 in these two rows, right? 7 cannot be here, cannot be here, in this row. We know 7 can't be in row 6, so the 7 in the 7. Oh shit! It doesn't have to be there. So okay. So the 7 would be in one of these two. The 7 cannot be here. The 7 cannot be in box. Okay, yeah. The 7 cannot be in box 5 because this is eliminated for 7. So it cannot be in box. Well, it can be. There's 2 spaces. It could not be, right? So then either the 7's here, or one of these two is 7, right? Okay, so the 7's actually still possible here. Right, then you would have... Okay, so let's remove all the 8's. So where could the 7's be? The 7 would have to be one of these two. One of these two. Assuming it's in a circle. It is not... Oh, wait. No, okay, yeah. That's okay, that's where I was getting confused. Okay. 7 cannot be in this box because it has to be in a red, and it cannot be, and the 7 blocks all of these. So it can't be in a circle in box 5. It can't be in a circle in box 4, and those are the only 2 it could be part of. Therefore, it has to be in a circle in box 7, so it has to be here. But the problem is that makes this not 7. So this has to be the 7, which means that has to be the 7. So that has to be 7. That has to be 7, which means one of these two is 7. Okay, wait, hold on. That actually works. what am I missing here? This can't be 7, so the 7's one of those two. So this one has to be the 7, right? Because the 7 is in one of these two spots. The 7 has to be one of those two spots. So it has to be on this row. It can't be here. So this is 7. This would have to be 7. Okay, so far this is okay. Okay, so this can't be 8, and it can't be next to each other, right? So this one has to be the 8. This one has to be the 8, right? And so this is, so we now know this is red. This can't be blue. So this is red. This is red. One of these is red. We don't know which one of these is red. This has to be red. This cannot be red because it cannot be orthogonally adjacent, so this can't be 8. Therefore, this is 8. So far, it's looking okay. Never mind. I thought I had something there. Okay. What if this were 8? If this was 8, this would have to be 7. Again, these would both not be blue, so that's red. This can't be 8. This can't be 8. This can't be 8. Oops. So this would have to be 8, which means that can't be 8, which means this would have to be 8. And this would be red, so neither of these could be red. So these would both be green. So this is 8, this is 8, this is 8. One of these two is 8. This can't be 8. This can't, okay, so this can't be 8. So this has to be the 8. Which means none of those two are 8. So 8's one of those two. 8's one of these 3. So this is 8. And it's red. So this can't be red. This is blue or green. Seven would have to be one of these two. 7 would also have to be one of those two. Right? Because 7 cannot be here. This is 7. It doesn't have to be, right? No, okay, yeah. So it has to be 7 here, right? So this is 7. This can't be 7. 7 is one of these 3. This can't be 7. One of these 2 is 7. This can't be 7, so this has to be 7. And it's red, which is fine. So this can't be 7, this can't be 7. So one of those two appears 7, which means this is 7. Right, because none of these can be 7. This can't be 7. So one of those two is 7. This is 7 and it's red. This seems fine. This is 7. So one of these two, one of these two, one of these two. Yeah, this seems reasonable too. This can't be 8. If this was 8, this would have to be 7. But then they would be red next to each other. So this can never be 8. Which means this would have to be 8. And red. This would be red. This can't be red. This has to be red and 8. So we'd have all the 8s taken care of. Oh, wait. That doesn't work. Contradiction. Right? One of these has to be 8. And we just... Let me double check this just to make sure. Okay. So if this is 8, this is 7, which means this has to be red. This also has to be red, so this can't be 8. None of these are 8, and this can't be 8, right? Therefore, this is the only one 8, so that has to be 8. This can't be 8. And this is red. The 7 is here. The 7 is here. This can't be 8, so this has to be 8, which means this can't be 8, so this is 8. But the problem is, where can the 7 be? The 7 cannot be in any of these spots. It cannot be in box 5 in a circle, and it cannot be in box 4 in a circle, so therefore it has to be in every other box in a circle, but it can't be in box 1. So that does not work. Okay, so then... Okay, so this cannot be 8 specifically. The other one can be. So therefore we know the 8's in one of these 3. I don't know how helpful that is, but it's something, I guess. We showed 8 and 7 seems to be okay. So if this was 8, this would have to be 7. Huh. Okay, so let's try this if this is 8. I think, yeah, it was fine. It seemed okay. Not blue, not blue. So this is red. This is blue or green. Oh, okay, so that can't be 8. This is 8. This has to be 8. So, oops. This is red then. Again, the 7 cannot be in box 5 in a circle because it can't be there and it can't be blue. So it would have to be here in the circle. So this is 7. 8 can't be here and 8 can't be here. 8 can't be in either of these. So therefore this is 8 and it's this red circle. Oh, that doesn't work. That doesn't work. Okay, we figured out something. So 8 can't be there because 8 would have to be here, but it's next to a red, and that's not possible. Actually, why did I not color that? Anyways. Okay, so we know 8's here. This can't be 8 anymore. Oops, 8 can't be 8. It has to be blue or red. So this is blue or green. Okay, so this can't be 8. Wow, that's a pretty big mistake of not doing that. Okay, so this is red. Right, so this is red. This is red. Let's just... These are all green. These are all blue. Actually, no. Let's just leave them be. Okay, so this is blue and green, so therefore the 8 has to be here, so this cannot be 8, which means we know this is 8, and it has to be red. So this cannot be 8. This has to be 8. Okay, yeah, wow, that's a pretty big, huh. Oh, well. So this is red, so this is blue or green. This could still be blue, right? So this is 8, this is 8. Okay, this can't be 8. So either this is 8, this is 8, this is 8, this is 8. Right. That's pretty big, yeah. Blue and green. So this would have to be 8. This is one of each. This is one of each. But we don't know. Interesting. So whatever's in this circle cannot be here, cannot be here. It could be here. But the key is that it has to be, this is different from this. It could be here. Hmm. We have the 8 there again. So everything could be 1 through 7. Hmm. So one of these is red. We don't know which. There's an additional red here. There's 3 reds. Wow. Hmm. Yeah, given that there's so many extra sets, that is not actually that surprising thinking about it. Um, can this be 7? Possibly, yeah. Okay, that is a good question. Okay, so if this is 7, we have this is 5, 6. It has to be 5, 6. So then we have 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. That seems reasonable. 7's in one of these, 7's in one of these, 7's in one of these. Okay, so first of all, this would have to be 7 here specifically. So then 7 would have to be here, which means 7 would have to be here. So this is 7. This would have to be 7. This is 7. So 7 would have to be one of those two. So if this is 7, this is 7, this is 7. So this would have to be 7. So this would have to be 7 and 6. This would be 7. And we don't know about this. So far this seems okay. This is 7. This is 7. Hmm. Hmm. This is a 7-9 pair. We'd have 1 through 6 in all the other ones. This seems okay right now. So this would be 1 through 4. 5 and 6 would have to be in a set, so this cannot be 5 and 6. I mean, it could be in both of these. Okay, so this has 3. Okay, maybe look in the boxes. Yeah, maybe the boxes would be good. Okay. In here, there are 6. So there's 3 outside. In here, there are 5. In here, there are 6. 3 outside. Here, there are only 3. Here, there are 5. Here, there are only 3. Here, there's 6. Here, there's 5. Here, there's 6. So there's none with 7. There's 4 with 6. There's multiple with 5. 3 with 5. And there's 2 with 3. Hmm. Hmm. Okay. Hmm. One of these has to be red, right? Because either that's 8 or that's 8. Therefore, this cannot be red. It has to be blue or green, right? If it's green, it becomes 2 reds, which seems fine. If it's blue, it could be a red and a green or 2 reds. We know one of them's red, though. Um, Hmm. Interesting. In this one, there's only 2 reds. Possible. But in this one, we have 3. So there's at least... Right. So this can't be red because it's blue already. This can't be red because it's blue already. This can't be red because it's next to the red. This has to be a red. But this can't be red because it's next to a red. This can't be red because it's next to a red. This one could be red. So right now, that means there's at least 2. For red, there's 2 extra ones. Or 1 extra set. At least. We don't know which, though. Hmm. Uh, if there's a red 7. Okay, that's interesting. If there's a red 7, it has to be here. And then it has to be here. Well, it has to be one of these two. But then it could not be here. So the 7 can never be red. Right? The 7, if the 7 is something, it has to be blue or green. It has to be blue. Right? Because the 7 would have to be here. There's nothing else here, right? So the 7 could be here, which would be it's not okay. If there's a 7, it's not in row 6, and it's not in box 4. So it has to be in all the other boxes. So for it to be in this box, for it to be in column 1, it has to be a blue or a green, right? And if it were a green, so it would have to be a blue. So this would be 7. This would have to be... Oh, that's interesting. Yeah, so what if... Okay. So if there's a 7, it has to be blue, right? In these columns, in these rows, we know... Okay, in row 6, it cannot be any of them. We tried... In row 5, it could be blue or red. But if it's red, that means it would have to be one of these two because it's not in row 6. It's not in box 4 already, and it's not in row 6. So that's 2 taken care of already. So it has to be in every other box. So box 7, it would have to be here. It has to be in the red. But then it would also have to be here, which means it would be in the blue, which is not possible. So the 7, if there's a 7, it has to be blue. And so it'd have to be one of these two. It would have to be specifically this one. And it would have to be blue. And you would have to have another blue, and it's 6, right? So this cannot be blue. So this is green. This cannot be green. So this is blue. This cannot be green. That's blue, right? So 7 would have... Oh, okay. Where does a 7... Ah, we see it. I see it. I see it. I see it. Yes, okay, so we figured it out. So if it's 7, that has to be 7, that has to be 7. This has to be 6, right? Because it has to be all the same color, so it has to be blue. Where is the 7 in 8 and 9 now? It cannot be anything in row 9 because there's no blue. But we already know... Okay, wait, hold up. Yes, we already know that 7 cannot be in row 6. So now 7 cannot be in row 4, not be in row 6, and cannot be in row 9. Therefore, 7 is the other one that's out. So we know 7 is the other one that's out. So this has to be a 7-9 pair. This is 7-9, and this is all 1 through 6. So we have each one is multiple. So 3 has to be in each row. So we know this is 3. and 3, this is the green 3. So either this is 3 or that's 3 or one of these is 3. So 3 cannot be in any non-circle space. So this cannot be 3, which means this can't be 1 or 2. This could be 4, 5, 6 or 5, 6, 7. Either way, 5 and 6 are here. So this cannot be 5 or 6. And it cannot be 3. So this 1, 2, no, it could be, cannot be 3, could be 4, cannot be 5 or 6, could be 7, right? So this is 7 or 9. The 7 has to be one of these 3. The 7 cannot be there. So the 7 has to be one of these 2, which means this is 7. So this is guaranteed 7. This is 6. This can't be 6. So 7 is not one of these. 7 has to be one of these 2. 7 has to be one of those 2. So 7 is one of those 2. 7 is one of those 3. So this cannot be 7. This can't be 7. So 7 is one of those 2. 7 is also one of these. 9 is also one of these. This can't be 6. So 7's one of these corner ones. This is 7. So there's 3 sets of 1, 3 sets of 2, 3 sets of 3, 4 sets of 4. Sorry, 2 sets of 4. And 1 set of 5 and 6. So 6 has to be here, which means none of these are 6. So we have 1, 2, 3, 5, 4, 5. And this is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. 6 has to be here. This is also 1, 2, 3, 4. 1, 2, 3, 4, 5. It can't be 6, can't be 8. This could be 6 here. This can't be 6, so this is also 1, 2, 3, 4, 5. So right, in all the circles we know... Okay, so this can't be 3. So we have... Okay. So this is specifically 7 and 9. That's 7, 9. This is 1, 2, 4, 5, 6. Okay. So this is 7. This is 6. There's also 1 through 6. So 3 is one of these. 3 has to be one of these. Okay, so since 3 is one of those, this can't be 3. So this is 1, 2, 4, 5, 6. These are also 1, 2, 4, 5, 6. And this can't be 6. One of them's red, and it's an 8. And one of them's green. So one of these is red, which doesn't help very much. We know this is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have all of them here. So 6 is either blue or green. We don't know which. This could be 6. Okay. Yeah, this is pretty tough. Again, this could be 7, 5, and 6. That's possible now. Oh, wait. Where is the 7 here? Oh, actually, we already knew that. Never mind. Uh, Hmm. Hmm. So 3 in one of the other colors has to be there, right? It's either in blue or blue and red. There's only 2 other green 3s. I guess part of the question is where is it, right? Yeah. There's also 3 red 3s and 3 blue 3s. Okay, so we know, okay. So 3 has to be here, which means 3 has to be one of these two. This can't be 3. Why can't that be 3? I don't. Okay, because one of these is 3. So one of these is 3, which means one of these 4 is 3. One of these 2 is 3. One of these 5 is 3. Oh, this has to be 3. Wait, no, 3 could be here too. Let's fill them all in. This can't be 3. This can't be 6. This can be 1, 2, 3, 4, 5. Okay. 5 and 6 have to be the same. Oh, that's interesting. It has to be the same color for each one, is the thing. Hmm. Hmm. Okay, so there's a 6 here. So we've got 2 out of the 4 missing 6s. Wait, no, it has to be 3 missing 6s. So 6s cannot have to be in a circle. 6 6s have to be in a circle. We are already accounted for 1 and 2. So we have a third. We don't know where that is. Oh, okay. So we have a 6 that's not in a circle in row 3. We have a 6 that's not in a circle in row 4. We know row 6 also cannot have a 6. So row 5 has to have a 6. All the other rows have to have a 6. So 6 is either here or here. And the other one is out. So all the other rows have to have a 6. So this has to have a 6. Okay, this is 1, 2, 4, 5, 6. This has to have a 6. Aha! All the other rows have to have a 6. So what we know is, okay, yeah, there we go. All the other, so row 2, sorry, row 3, the 6 is outside a circle. In row 4, a 6 is outside of the circle. In row 6, a 6 is outside the circle. Every other row must have a 6. So the 6 must be in a circle. So in row 9, we only have red and greens. So 6 cannot be a red, cannot be a blue. But in row 5, there's only one possibility for a 6, and that would have to be this one because it can't be blue. So this one has to be 6, and it has to be green. So we know 6 is a green. So this can't be 6, this can't be 6, this can't be 6. So we know 6 is over here. So this can't be 6, which means one of these two is 6. So this can't be 6. So this can't be 6. Right, that can't be 6. Oh, wait, no, that's not true. Oh, this is this. So 6 cannot be in a red. 6 cannot be in a red. 6 has to be one of those two. 6 can't be in a blue. 6 can't be in a red or blue. This can't be, yeah, this can't be correctly. So 6 is one of those two. 6 is one of these two. So 6 cannot be here. 6 can't be here. These can't be 6. This can't be 6. This can't be 6. Therefore, this has to be the 6. So this cannot be 6. So therefore, this is the 6. So that eliminates 6 from all of these three. Therefore, this has to be a 6, and it's this has to be 6, and it's green. So no 6 here. So the 5 is here, which means 5 cannot be anywhere on this column. So this is 6. One of these two is 6. We don't know which. One of these two is 6. Okay, this can't be 6. So in the bottom row, this one has to be 6. So this can't be 6. This can't be 6. This can't be 6. One of these two is 6. And it's green. And there's also a blue there too, but we don't know which one's which. So all the 6s are accounted for. So this can't be 6. So this has to be a 6. Which means this is green. So this cannot be green. So there's no 6 here. So this is 6. Okay, this has to be 8 then. This is 8 and a red. So this can't be 8. So this is 8. This is 8 and a red. So this can't be red. This is blue. So all the 8 should be... Okay, well, not completely. So 6 is one of these two. We don't know which. 8. 8 is one of these two. 8 is one of those two. We don't know which. So this becomes blue or red. This is blue. This is green. Red. Green. Yeah, this is fine. Okay. Hmm. Okay. This is 6. If this was 6, this would have to be 5. And then 5 would have to be in all the greens. Would that be possible? Okay, so let's try that. So if this was 6, this would have to be 5, and they would both be green. So they cannot be blue. This can't be green, so this is blue. This can't be blue, so this can't be red. So this can't be 5. This can't be 5 or 6. Neither of these could be 5. So this would have to be the 5. This couldn't be 5. This couldn't be 5. No 6. This would be the 6. So this could not be 5. So you'd have 1, 2. So this could not be 5. That can't be 5. This can't be 5. This can't be 5. This could be 5. This can't be 5. So we have 1, 2, 1, 2, 4. This would be 5 or 9. So this would have to be 9. This would be 5. This would be 9. So this cannot be 5. That can't be 5. Therefore, this would have to be 5. So we have 1. Okay. So the 5 would be one of these outside the circle. So this cannot be 5. This cannot be 9. This can't be 9. So this would have to be 9, which would make that 9. This would have to be 9. So this would be 7. So this would be 7. This would have to be 5. So this would be 7. This would be 7. This would be 9. So this would be a 7, 9 pair. This would be 7. And 1, 2, 3, or 4. So there cannot be a 5 here, which means this would have to be a 5. So this cannot be 5. 1, 2, 3, 4, 8. 5 cannot be here. So 5 is one of those two, which it cannot be because it cannot be blue. So then it would have to be here if that's the case, right? But you'd have 1, 2, 3, 4, 5 already that are out, which does not work. So we know this can't be 6 then. Okay, so that's... this is so inelegant, but I don't know if there's any other way you can do this. Anyways, so this cannot be 6, so this has to be the 6. So this is green. So this can't be green. Therefore, this can't be green. This is blue and blue. This can't be 6, so this is 6. So that's all the 6s. They're all green. So this is blue and blue. Which makes that blue. Okay. Can 5 be red is another question, right? 5 could be red. There are 3 sets of 3, 3 sets of 2, 3 sets of 1. So this is 3, this is 3. Any of these 5 are 3. One of these is 3. Then we have a set of 3 and a set of 3. I guess it's a set of 4 technically, but okay. So this can't be blue. This has to be blue or red also. So this cannot be. So this 3 here is blue or red. This one could be any of them. This one could be any of them. This one could be any of them. This is obviously green. This can be any of them. This is blue or green. This can be any of them. This can be any of them. Okay. We have 2 sets of 4. Okay, that's interesting. We have 2 sets of 4. We have 2 sets of 4. How many sets do we have? Again, how many boxes do we have? Where there's 3. Oh, no, wait, that's, yeah. Never mind. Oh, wait. No, that actually works. How many of them that only have three, right? Or, sorry. How many of them have six circles is the question, right? Because if there can only be at most six rows or six columns or six boxes with six circles at least, right? Because two has to be in three sets also. So it has to be in six spaces. So two also has to be there, right? So this is 1 6, so that's one. This is two. Three, four. No, okay, that no. That's not correct. That's not the way to think about it, or at least. Oh wait, maybe. Hold up. Four has to be in all the circles except for one, right? So four has to be in all the circles except for one because it's in eight of them. Two has to be in all the circles except for three. So that takes care of four spaces that you cannot have, right? And that's all six, right? So say, okay, you know seven and nine in each box or each column or each row are out of the circles. What about fours and twos? Fours has to be in eight of them. So that means there's only one spot. Oh, no, that's not right. That's not correct. Hmm. Wait. So it has to be a one, a two, a four or five in the last blank spot. A one, a two, a four, or five. There are four ones in there. There are six. No, sorry. There's six ones. There are four fives. There's three twos, and there's one four. So one of one, two, four, five is here. So one of one, two, four, five. Okay, so how many is that? That's six ones. So that's six plus four fives. So that's 10. 14. That's a lot. And this would be one extra. This would be two. This would be three. So one, two, three. This has a lot. This has three. This has a decent. No, this has one. So we have one, two, three, one extra ones. This has three extra ones. This has one extra one. This has. So this is three extra ones. So this has three extra ones. So we have three extra here, three extra here. This is one extra one. These are two extra ones. And this is one extra one. Not too helpful there. What about rows? Rows, we know the 1 is in one of these. 1, 2, 3, 4, 5, and 6 are all, or 1, 2, 3, 4, and 5 are all here. Oh, the 4 has to be in row 6. So for all the other rows, 4 cannot be. Yes, okay, so 4, okay, there it is. So 4 has to be, cannot be in a circle in row 6. So therefore, in all the other rows, it has to be in a circle. So this cannot be a 4. This has to be a 5. This cannot be a 4. This has to be a 7. This can't be 7. Therefore, this is the 7. So this can't be 7. So this is 7. So this can't be 7. This is 9, which means this can't be 9. So this has to be 9. This can't be 9, so this is 9, which means that's 9, which means that's 9. And so this is the 7. So this can't be 9, so this is 9. Wait, that doesn't work. No, 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 no. Okay. Oh, okay, yeah. I nearly messed that up. That would have been bad. This can't be 9. This has to be 9, which means this is 9. So this can't be 7 or 9. So this is a 7-9 pair, so this can't be 9. This has to be 7, so that has to be 9. No, 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 no. Okay, that is breaking it. Oh, okay, I see it. Never mind. This has to be a 7-9 pair, so this can't be 9. This has to be, okay, so this can't be 7 or 9. Therefore, this is 9, so none of these can be 9. This can't be the 7, so this is 7, and this has to be 9. So there we go. So that can't be 9, this is 9. So this cannot be 5. This cannot be 5. This can't be 5. So this has to be, this can't be 9. This is 1, 2, 4, 5. This can't be 9. This is also 1, 2, 4, 5. Oh, but yeah, this is 1, 2, 4, 5. So 1, 2, 4. So the 5 has to be here, which means this can't be 5. So 4 has to be in circles in all the other rows besides row 6. So this can't be 4. These can't be 4 besides row 6. So this could be 4. This can't be 4. This is 1, 2, and 5. This is 1, 2, and 5. This is 1, 2, and 5. This can't be 5, so it's 1 or 2. This is 1, 2, or 5. 7, 9. So this would be 9. It can't be 9, so this is 9. And this has to be 7, 9. So this is 7. This is 7. This is 1, 2, or 5. So this can't be 7. Okay. Now we do coloring. Okay. So 4. 4 could be here, or 4 could be here, or 4 could be here. We don't know. 5 has to be here, which means 5 is one of these two. Interesting. So 5 cannot be here, because this is 5, 7. Okay. So again, 3 has to, okay, so this is 1, 2, or 5 also. 1, 2, 5, 1, 2, 5. All right, so this could be 4, in which case that's not 4, in which case one of these two is 4. 3 has to be here, and it could be blue or green. Okay, 5. We have 1 that's outside. We need, what, 3 additional ones? Yes, 3 additional ones. So one of these is outside, so that's 2. So we have 2 that are outside. This could be 1, this could be 1, this could be 1. This is not outside, so this is solidly in, so that's 1. We don't have anything else that's solidly in. Hmm. Hmm. Interesting. Okay, 3 or 4 has to be in one of these, at least. It could be in both, but 3 or 4 has to be at least in one of these, which means the other one has to be 2, 3, or 4. 2, 3, 4, 5. Hmm. Can the 5 be in blue? Let's just do that. Okay, so this would be 5. This would have to be 4, right? No 5, no 4. So the 4 would be here. Therefore, this would be 4. But it could be blue or red. This would have to be 3 or 5. So this would be 3, which would make that 5. So this would have to both be blue. So if this one is blue, so this cannot be here. Therefore, this is a 5. Whoops. This is a 5. This could be a 4. No 4, 5. No 4, 5. No 4. No 5. No 5. So this can no longer be 5. This can no longer be 5. That can't be 3, 3, 5, 4, 4, 4, 4. 5 is one of those. We have 3 5s that are outside, so this is 5. So one of those 2 is 5. So this sort of seems it could be valid. This can't be 5. So in this column, the 5 is outside. So, and we have column 1, column 3, column 5, and column 8. They're outside. So in column 9, all the other columns, they have to be in. So this has to be the 5. This would have to be 5. Column 6, we don't know which one. So far this is looking okay. Yeah, that's looking okay. I'm not sure how else you can really test this except just go through everything. So this can't be 4 because the 4 has to be one of those 2, which means this is the 4. So we have a blue and a red. So this can't be 4. So this cannot be 4. So this is 3. This is 1 or 2. This is 1 or 2. This can't be 3. This has to be 4. We don't know if it's blue or red, though. This is 1 or 2. This can't be 4. This can't be 4. This can't be 4. So 5 could be one of those 2 or one of those 2, right? Right. 3, we don't know which. This is a 1 or 2. Yeah, this is looking okay. Not great. So 3 is one of these. It's either blue or green. We don't know which. Oh, this can't be green. Okay, so for one thing then, without going through all... Okay, so Uh, yeah, that's one problem. Okay, this can't be green. This has to be blue. I'm not sure if that gives us anything, but that, yeah. I missed that orthogonality. So this has to be blue. Uh, can't be red because 8 is in either side. Uh, hmm. Yeah, okay, so that 5 looks like it's still okay. Oh, this can't be 5. If this was 5, this can't be 5, but then this would have to be 5. And then we have a green and a blue 5. Okay, so that's one thing that's easier. So this cannot be 5. What about this being 5? If this is 5, this has to be 4, and that would be 5. Okay, so that's okay. Interesting. Okay. Okay, so what about if the 5s are green, right? So the 5 is either green or blue. So say if the 5 are green, this can't be 5, this can't be 5, this has to be 5. This can't be 5, therefore this has to be 5 because neither of them can be green. So we have 5, 5. This can't be 5 because it can't be green, so that's 5. That can't be 5. Okay, and then we just don't have enough now, right? We have 1, 2, 3, 4, 5 that are outside the thing. So 5 cannot be green. So we know that for certain. Therefore, this has to be the 5. That has to be the 4. Where is the 5 here, right? So this cannot be 4, 5. This can't be 5. Where is the 4? The 4 cannot be anywhere here. So this has to be a 4, right? So this becomes 3 and 5. But this has to be 3. So everything that we followed down was correct then. So this has to be 5, which means it has to be blue. So it cannot be red. This can't be red. This is blue. This can't be 4, 5. This can't be 4, 5. This can't be 4. And it can't be 5. Therefore, this is the 5. So this can't be 5. This has to be the 5. So this can't be 5. This can't be 5. This can't be 4. This can't be 5. So 5 can only be in the blues, so this can't be 5, this can't be 5, this can't be 3, this can't be 5, no 4, this can't be 5, this can't be 5, no 3, no 4. So again, we have 5s in 1, 2 outside circles, and 1 in column 1, 3, and 8. We also know in here, it cannot be here, which would be the only valid circle. So in column 5 also, the 5 is out. Therefore, the 5 has to be in all the other columns. So other than 1, 3, 5, or 8, everything has to be in a circle. So this has to be 5, which means this can't be 5, which means this is 4. So this can't be 5. No 4, no 4. This can't be 5, that can't be 5. So none of these are 5. This has to be a 5. And we don't know about these two. And this was an area where we ran into like we just got a little stuck here. So this is fine. So the 4s can only be in blue and green. It cannot be in, sorry, blue and red. It cannot be in green. So this is 1 or 2, which forces this to be 3, which forces this to be 1 or 2, which means this is 4. So this is blue or red. We don't know which. This can't be 4. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3. So this becomes 8. This has to be 4. This has to be red. This is blue or red. So this is blue or green. We don't know which. This is also blue or green. We don't know which. So this can't be 8. Therefore, this is 8. So this is not green. This is red. This can't be 4. This can't be 4. So 4 is here. 3 is here. This can't be 4. So this has to be 4. and it's red. So we have 2 reds, 2 blue 4s, and 2 of any color. Okay, this is 1, 2, or 3. So we have 4, 5, 4, 5. We might need to start coloring the 1, 2s. 3. Okay, where are the possible red 3s? Here, cannot be here. Here, here. So one of these is green. So we have green or blue. We have green or red. We have green. We have green or blue. This could be blue, green, or red. This is blue, green, or red. This is green or blue or red. Ugh. Okay, so this has to be 4. This cannot be 4. This cannot be 4. Yeah, so this has to be 4. This can't be 4 because the 4 has to be valid. So we have a blue 4. We have 3 blue 4s. We have 2 red 4s. We don't know where the other 4 is. Okay, so this can't be 4. So this is a red 1 or 2. This can't be 4. Right, it can't be green either. Okay, so this is 4. Which makes this 4 and this 3. Okay. This can't be 3. So we have... Okay. Unfortunately, this doesn't tell us anything. These can be any color. Okay, well... So we know this is green. Oh, this is 1, 2. This is 1 or 2. So this cannot be 1 or 2. This cannot be 1 or 2. So it's 3, 5. It could be the same color. Hmm. Okay, let's color these something. Yellow. This is orange. So this is orange. So yellow has to be one of these two. Orange is here. Yellow and orange could be here. So this is yellow. So yellow's here, and then it's also here. That doesn't tell us very much. Okay, so this is orange, right? So you have yellow, orange, this is orange, this is yellow. This has to be yellow then, which makes that orange, which makes this yellow. So this cannot be yellow, therefore this is yellow. So these are yellows. This is yellow. This is yellow, this is yellow, this is orange. This is yellow. So yellows are the same number. And this is blue? Is that right? This is blue. Okay, so yellow's here. Okay, where's yellows? Yellow's one of these two. Yellow's one of... Okay, yellow cannot be here, right? Because that eliminates there. Therefore, this is yellow. So we have that's yellow, that's yellow, that's yellow, that's yellow, that's yellow. So yellow's in 4 circles already. So yellow has to be 2. So let's remove the multiple yellow. So this is 2. Okay, so remove the yellow. Okay, so we have 2 in blue. Okay, so this can't be 2. This can't be 2. This can't be 2. This is, okay, so oranges are 1s. So these are all 1s. So remove oranges. So this can't be 1. This is 3 or 5. This is 1 or 3. This is 1 or 3. Okay, so we got... Okay. So either that's blue or that's blue. We don't know which. This has to be 3 then. So this is 3. This is 2. This is 1. This is 3. So this is 2. We have 1, 3, 1, 2. Okay, now we have coloring. Okay, so 2s. We have 2 greens, so this cannot be green. So that's 2, 2. So there's no blues anymore for the 2s. So this cannot be blue. This is red. So this cannot be green. So this is red. So we have red, blue, red. Okay, that's fine. Okay, 1s. We have a red 1 and a green 1. And we can't... So this either this is blue or that's blue. We don't know which, right? If this is 1, this is 5, then that's 3. Okay, how many 3? So we have 2 green 3s. We have one of these is blue. How many red 3s do we have possible? We only have 2 right now. So this has to be a red. We know none of these can be red. So one of these has to be red, and this has to be the red, and it has to be 3. So then this becomes 5, which means this can't be green. So this is regular. This is so this is 1. This has to be 3, 1, and 5 then. Whew. That was pretty tough. Yeah. It felt like, though, you can consistently go forward as long as you're thinking about the rule set here, because it's very... There's very particular things that you can do. Okay, we gotta finish the coloring here. Okay, so this can't be red, so this is blue. How many 4s do we have now? We have 1, 2, 3, 4 blue reds, so this cannot be blue. So this is red, and this is red. And then there you have it. That's the solution for all the coloring. Yeah, it's very interesting. Like, for example, figuring out. I guess it just sort of kept on running into itself, right? So the 9 forcing this to be essentially non-9, right? You counted up the number of circles, which is 61, and you subtract 9, and you get 52. So 8 had to be in a circle. So 8 had to be in a circle because you know there was a 9 here. And the 9 forced the 8 to be somewhere. So the 8 had to be outside, and then inside for every other row, column, or box, which gave you a lot of different things you could go through. Then you had 7s, where basically the 7... I forget exactly what you went through, but you went that the 8s could not be here, right? The 7s could not be here. You tried to have a 7 as a red. Actually, you just tried to have it as anything, and it just didn't work. And then you had this, because of that, you knew that the 7 was out of the circles. So therefore, every other combination had to be in the circle, which gave you 3s, had to be in every row, column, and box, which gave you 3 there. And then you said, because of that, you had 4 had to be in every one but 1, which gave you a lot of differentiations that you had to have. And then you had to figure out where 5s were. And then everything else flowed pretty quickly from there. Interesting, very, very interesting puzzle. Definitely very hard. something you need to think through and something you need to go through slowly to eliminate possibilities. But I hope you had a good time during the solve, and I'll see you next time on Frank Puzzles. Take care.